Hello, everyone. Happy Monday from where I'm standing. It's a beautiful day outside. Hope you enjoyed the good weather over the weekend. We are beginning set theory here in statistics. So, for the rest of the year, probably we're going to set the actual statistics aside for a long time now. You probably won't even need to pick up your calculator. We're going to start doing a little set theory today in order to move towards probability. Probability is our big topic. We're talking about set theory to kind of introduce that big topic of probability. We have a learning target. I can operate with sets and list the intersections, unions, and complements. All right, let's just kind of run in with the basics of set theory. So let me introduce to you this first one here. This is slide 4. Let me just talk about what a set is. What is a set? All right, a set is a collection of elements. All right, it's a collection of elements. It's a collection or list. You might think of it as a list of elements. And what are elements? Elements are the things in a set. In a set. All right. A little circular logic there. I know, but this is kind of the fundamental concepts. There's a set. A set is a collection or list of elements. What is an element? Elements are the things that are in a set. Okay. Now, I don't think this is a Venn diagram because there's 3 circles, but we've seen these before, right? So sometimes we'll do a visual representation of a set. We'll draw a circle, and then everything inside the circle A is within the set A, and then we have the circle B. Everything within circle B is an element inside of the set B, and anything inside circle C is an element within set C. And a union, and I like what Ms. Desiato, the metaphor she used. A union of set is like a marriage. I like the way to think about this. Everyone is invited. No repeats. A little bit longer. So a union of sets is like a marriage where everyone is invited and there's no repeats. All right. I think of this as an or. Right. The union to me is an or sign, like a logical operator. If you know your symbolic logic, it's anything in A or anything in B. All right. The union is anything in A or anything in B, or the union is like a marriage where everything in set A and everything set B is combined. Everyone's invited, no repeats. That's important. Okay, so I have set A here. Set A is equal to 0, 2, 4, 6, 8, 10. Set B is equal to 1, 2, 3, 4, 5. All right? In a union, if we have A, union B, that little U there is the symbol for union. If we have a union with set A and set B, then we need to have 0 because it's in set A, 1 because it's in set B, 2 because it's in set A, 2 is also in set B, but no repeats, 3 because it's in set B, 4 because it's in set A, 5 because it's in set B, 6 because it's in set A, and 8 because it's in set A. And that's where I stop my... Oh, wait, I forgot 10. I missed 10. How did I miss 10? 10 because it's in set A. There I go. I've combined all the elements that are in A and B. Notice I don't have a 9 in here, right? Because there's no 9 in set A or B. So it's not going to be in the union of A or B, right? So a union is like a marriage where everyone's invited and there's no repeats. You combine whatever is in both sets together into one bigger set. And it's also like anything in A or B. List everything, no repeats. All right. If you need this, pause me. Otherwise, I'm moving on to slide 5. Slide 5. An intersection. All right. An intersection of 2 sets is the set containing all elements common to both sets without listing anything more than once. So an intersection is, to me, like an and. An intersection of 2 sets is just the elements that are shared between A and B, right? The intersection is where these 2 circles overlap. It's only the elements that both A and B share together. All right. So I have set A here, which has the elements 0, 2, 4, 6, 8, 10. and set B here, which has the elements 1, 2, 3, 4, and 5, if I'm going to list an intersection of A and B, I can't use 0 because it's not shared. I can't use 1 because it's not shared, but 2. 2 is shared between them, so I can use 2. I can use 4. 4 is shared between them. Can't use 3. That's not shared. 6. No, I can't share 6. Actually, that's it. That's it. 2 and 4. 2 and 4 are the only elements that are shared between A and B. Therefore, they're the only elements that show up in the intersection between A and B. All right, so this is the intersection of A and B. Intersection, A and B. All right, only the things they share. All right, pause me if you need this. Otherwise, I'm moving on. Slide 6. Slide 6. If an this isn't going to make sense right now, probably until you learn more about set theory, but just kind of give an idea. If an intersection is an empty set or null set, this means there are no elements in common, and we say the sets are disjoint. So it's possible to have a set that has no elements in it. All right, you can have a set that has no elements in it. We call that set an empty set or a null set. And you can either use just two brackets with nothing in between them. That's one way to talk about an empty set. You can also use this little symbol here, which is the null symbol. It's like a 0 with a little line through it. That's the null set. It's not the number 0. It's null. It means empty. All right. Okay. And then we can also talk about what's called a universal set. The universal set is like the opposite of a null set. The universal set is the original set of all possible elements that may be used. All right. The universal set is generally given by the letter U, not to be confused by the union symbol. So this is how this looks. It'll say like U equals, and that U, when it's out in front here, right? The U, when it's out in front here, when it says U equals, means, hey, this is my universal set. All right, so my universal set is equal to the list of elements 0, 1, 2, 3. And you see these little three dots there? Those three periods there are called an ellipsis. An ellipsis, all right? And what it stands for is it says, and everything in between 3 and 9. And everything in between 3 and 9. It means I've abbreviated this list somewhat, but you can figure it out. Okay, and we can figure it out, right? If we start with 0, go to 1, 2, and 3, we can see that we're counting by positive integers. So I know that the universal set here includes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? That little ellipsis says includes 4, 5, 6, 7, and 8. That's what that little three dots mean. It means the universal set includes 4, 5, 6, 7, and 8, as well as the numbers you see there. All right, then we have set A. Set A only includes the elements 2, 4, 6, and 7. All right. What we're going to look at next is ask ourselves, what's the complement of A? And here is what the complement of A is denoted by. The complement of set A, as denoted by, there's 4 different kinds of notation here, which gets kind of confusing. Sometimes we use this notation, which is set A, and we will put a little C in superscript. That means the complement of A. Or sometimes we'll use an A, and then we'll put a little like quotation mark, single quotation mark there. And that'll be the complement of A. Sometimes we put a little line over top of A to say, hey, the complement of A. And then sometimes we put this little symbol here. It's called a tilde. This little squiggle is called a tilde. You can find it by the 1 key. Right to the left of the 1 key on most keyboards, you'll see the tilde. Sometimes you can press Shift and tilde to get that little symbol. It often means, in logic, it means not. So you could read this as not A, right? Tilde A means this, whatever is not in set A. Or also, all these actually all mean the same thing. The complement of A is whatever is in the universal set that is not in list or set A. Okay? So here we go. Our universal set is 0 through 10. Set A is 2, 4, 6, and 7. Therefore, the complement of A is going to include 0, because 0 is not in set A. It's going to include 1. It's not going to include 2, because 2 is there. It's going to include 3, but not 4. 5, but not 6, because 6 is in set A. It's not going to include 7, because 7 is in set A. And then 8, 9, and 10. My complement of A is going to include the set of elements 0, 1, 3, 5, 8, 9, and 10. Those are the elements in the complement of A, because they're all the elements that are in the universal set, which are the set of all possible elements that can be used for a particular problem, and they're all the ones that are not in set A. All right. Okay. Moving on to the next slide. Example 4, union. All right. Normally we'd have you in class do these. Probably pause me now is the best option right now. If you want to learn the maximum amount you can learn from this, you're going to want to pause the video now. You're going to want to try this and then come back and see how you do. All right. You're not just going to watch me do this, because that's not going to be have the best outcome for you. All right. Do what's good for you. Through the magic of video, I'm on pause. Great. All right. I see set A. Set A. I'm going to do a union between set A and set B. See? A, union, B. All right, remember what a union is? A union is a marriage where everyone's invited, no repeats. Okay? Everyone's invited, no repeats. It's anything in A or B. So I'll need a bracket. 0 is in set A, so that belongs in my union. 1 is in set B, that belongs in my union. 2 is in set A, that belongs in my union. No 3, no 4. 5 is in B, set B, and then 6 is in set A. Whoop, there we go. That is the list of elements in the union of A and B. The union of A and B. The union of A and B are going to combine all the elements from both. All right? Okay. Intersection. Remember what an intersection is? It's all the elements they share together. So an intersection of A and B will be a set of all the intersections of all the elements they share together. So let's see. I need brackets. Brackets are very important here. 0 is not shared, so I can't include 0. 3 is not shared. I can't include that. 5 is shared. 5 is shared, so I can include 5 in my intersection. Sorry. 10 is not shared, so I can't use that. 6 is not shared. Oh wait, 10 is shared. No, my bad. 10 is shared, and that's it. That's all the elements that are shared in the intersection between A and B. Intersection of A and B. All right. All the things they share, no repeats. And then the complement. The complement is everything not listed from the universal set that's not listed in A. Okay? So here goes. Hopefully you already paused me. You already tried this. Remember, you'll learn more if you try these. I need brackets. That's important. Let's see. 0 is not mentioned in A, so that is included in my complement. But 1 is in A, so I can't use 1. 2 is in my universal set. It's not in my set A, so I can use 2. Let's see. 3 is in set A. Can't use it. 4 is not listed. Is in my universal set, but not listed in set A. Can't use 5. 5 is in set A. I can use 6, though. That's in my universal set. It's not in set A. Can't use 7. That's in set A. I can use 8, though. And then I can't use 9, but I can use 10. Bracket, close bracket. And those are all the elements in the complement of A. This A, a little single quotation mark there, that's the complement of A. All the elements that are in my universal set that were not listed in my original set. All right, here's another one where you just want to pause and give this a shot on your own. All right, we've got a union of A and B here, an intersection of A and B here, and the complement of an intersection. Give that a try. Pause me now. Try it on your own, because you learn more when you try it on your own. Great. I'm back. I am back. All right, the union of A and B. Here's my union. Here's my universal set, sorry. My universal set is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My set A is 2, 4, 6, 8, 10. Set B is 1, 2, 3, 4, 5, 6. Okay, the union between them are going to be everything together. So I can include 1. I can include 2. Right? They both have that. I can include 3, 4, 5, 6. And I can include 8. And I can include 10. The union is everything. Oh, I need brackets. That's important. There is my set of the union between set A and set B. I just included all the numbers in set B and included all the numbers in set A. No repeats. A union is a marriage. Everyone's invited. No repeats. Don't invite anybody twice. Okay. Then intersection. An intersection of A and B. Oh, I forgot a little comma there. All right. Intersection of A and B. You've already tried it because you paused me. Good for you. Good for you. All right. Intersection. Only the things they have in common. Intersection is only the things they have in common. It's the things that A and B have in common. The intersection is only the things that A and B have in common. So 2. They both have 2 in common. They both have 4 in common. They both have 6 in common. And then that's it. That's it, right? Because B stops at 6. All right, now let's think about the complement. The complement of A intersecting with B is going to be everything in our universal set except the ones that are in our other in our intersection of A and B. Okay, let me try this. So if the universal set is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, and then I should probably put brackets in here. If let me show you how to do some of these symbols here. A, go to format. Oh, gotta get my face out of the way. Format. No, insert special characters, and you can type union, and you'll find the union symbol. If you want, you can also find intersection that way too. The union. Oh wait, no, I wanted intersection, didn't I? No, I didn't. I did want intersection. My bad. Special characters. I think intersection right there. Go intersection of A and B. Right, that's 2, 4, 6. I need a little equal sign. Boop. I need some brackets. 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 All right. So now what I want, a little copy here. I'm going to get rid of this, and I'm going to put a little tilde out in front to say, hey, I need the complement of what goes on in here. Okay. Well, so the complement of a set of the intersection of A and B is going to be everything from the universal set, which is not in my intersection. So 2 was in my intersection, so let me get rid of 2. Let me see. Format, text, strike through, Alt-Shift-5. I'll remember that. 4 was in my intersection. So Alt-Shift-5, crossing that out. 6 was in my intersection. Cross that out. Alt-Shift-5. Good. And now I can begin to list everything that is the complement of the intersection of A and B. 1 is in my universal set, but not listed in my intersection of A and B. 3 is in my universal set, but not listed in A and B. 5, 7, 8, 9, and 10. Those are all the numbers. All right, I can combine that here. 1, 3, 5, 7, 8, 9, 10. All the elements that are in my universal set that were not listed in my intersection of A and B. Whew. Okay, next slide. Next slide. Pause me if you need this. Or go back. That's the beauty of video. You can always go back. All right, I've got a union of A and B. I've got an intersection of A and B. I've got the complement of the union of A and B and the complement of the intersection of A and B. Pause me because you'll learn more. You will learn more. You'll feel like you're learning if you just passively watch, but you won't really get that learning experience. Your brain never engages the drive. You know what I'm saying? You need to put it in gear. Put that brain in gear and give these a try by pausing me. Right or wrong, you'll learn. All right. If you get it right, then you got it. You had an extra little practice. If you get it wrong, then once you see when you got it wrong, your brain will be like, "Oh my gosh, I'm surprised that I got it wrong," and then your brain will correct it, and it'll correct it very powerfully. You learn more when you get things wrong. So even if you get it wrong, go for it. Do it because you'll learn more that way. All right. Enough me talking at you. Trust the science, people. Trust the science. It's the neuroscience. We understand a little bit how learning works now. Okay, through the magic of video, you've unpaused me. A, union B. There's my universal set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My set A, 1, 3, 5, 7, 9. And set B, 2, 4, 6, 8, 10. The union. All right, the union. Everyone's invited. No repeats. 1, 2, 3. Right, 3 is in set A. 4 is in set B. 5, 6, 7, 8, 9, and 10. Right, look at that. The union in A and B is the exact same set. It's identical or materially equivalent with my universal set. Oh, that's nice. All right, let's do the intersection. The intersection. This one was probably pretty easy. This one might have been a little bit harder for you. This one might have been a little harder for you. Oh, look at that. I'm anticipating too much. This one actually, let's think about it. It's because the intersection are the things they share in common, right? And they don't share any number in common. All these numbers are odd. All these numbers are even. They don't share any numbers in common. So what we do is we just do some empty brackets. Another thing you can do is you can go to the Google and do null symbol, and then you can just kind of copy that symbol, Control C, and where was I? Where was I working? There was I. And you can do so. You can do that little. You could do that little number, or you could do one of these. That null symbol in some brackets, and you're also good to go. Empty brackets are probably just easier for you to do. Okay, now what we have here is the null set. I'm sorry, the complement. The complement of A union B. Well, the complement of the set of A union B would be any number that we left out of A and B. It can't include any number that's in the set of A union B, right? It's everything we left out. And our set of A union B has all of our numbers from our universal set. So this becomes a null set. It's an empty set. There are no elements in the complement of A union B. All right, it's an empty set. It's a null set. Because all of our elements were already, from our universal set, were already in A union B. The complement of A intersection B. The complement of A intersection B. Well, if A intersection B is a null set, then the complement of that would be everything in our universal set, which is not in our null set, which is all the elements from the universal set. There we go. It's all the elements from the universal set. It's the opposite of the null set. So the null set is the opposite or the complement of the universal set, and the universal set is the complement of the null set. All right, kind of feel how that works? All right, that is where we're going to leave it today, and we will pick up tomorrow. Hope you enjoyed this, and I'll see you in class.